Following on from my presentation this morning, I'm hoping that we can take a bit of a deeper dive into a few of the core materials we engage with as building professionals. So that's materials that can impact heavily on this climate and biodiversity crisis that I keep banging on about. And how might we do things better with our material specifications? Well, what about wood? The recent sixth assessment report of the Intergovernmental Panel on Climate Change, or the IPCC, it references the world's forests many hundreds of times, not only for their ability to sequester atmospheric CO2, which we heard about this morning, but also because they're crucial holds of biodiversity and carbon, and so seriously threatened by wildfire, heat-related dieback and other decline, which is occurring in our native forests big time now, impacting on and being impacted by climate change in what's a frightening feedback loop. So in this infographic, you'll see that boreal, so those northern hemisphere cold climate forests, tropical forests and temperate climate forests are the land systems with the densest above ground carbon storage. The coloured land areas here, they show the world's forests. So up the top, that great big band right across the planet of all that green and other colours, they're those boreal forests. The hot climate wet tropical forests of Central Africa, the Amazon of course, Southeast Asia, PNG, and the temperate climate forests, so the eastern seaboard of Australia, a little bit in Western Australia, parts of China, western side of the USA, that temperate climate forests. Deforestation of the northern hemisphere's boreal forests. They're the largest terrestrial, that's being the largest terrestrial biome on the planet. That'll have catastrophic impact on our global climate if it continues at the rate it has. It's true that much clearing of tropical forests is done to win agricultural land for grazing and for cropping. But certainly, much of the wood used for building construction in Australia is sourced in ways that damage the crucial ecological values and the climate stability that natural forests provide. So you'll see, as make it wood and it's the ultimate renewable. The truth of the matter is that timber can be a very good or a very bad material to build with, and it depends all on where and how it's sourced. So let's start with structural timbers because that's where most wood in buildings tends to go. Those very slow-growing cold climate boreal forests are where much of our simply sawn framing wood in Australia comes from these days. And anecdotally, it seems to me somewhere between 15 and 50%, depending on global market flows, certainly in Victoria. Our local pine and this imported spruce are stacked together on the racks in your timber yard. No labelling to differentiate them, same price. But check the end grain and it'll tell you the story. So on the left top, you'll see there's about anywhere between 5 and 9 years of growth in a stick of that stick of 90 by 35 framing pine. On the bottom at the right, I can count around about 29 to 30 years across that 35, but you'll see it through the whole timber, there are some 100 years of growth. So each ring is a year in the growth of a tree, certainly in the colder climate and temperate climates, a bit different in tropical areas. This tells me that forest carbon debt incurred if we use slow-grown boreal forest pine will take 4 to 8 times longer to repay or return back to nature than if we use fast-grown local plantation pine. So something like 80 to 200 years instead of 25 to 30 years. And in the time that we've got left for impactful global climate action, that's a problem. So I really encourage you, if you can, insist that your builders order timber grown locally in Australia in the warmer climates. At Mullum Creek, we did that. We did very regular checks on site And we tried to, if there was a problem, we tried to catch it before they unpacked the pack, because often it wasn't the builders who made the mistake, it was actually at the timber yard where the mistake was made. The same applies to engineered timber products. Like most of the laminated veneer or LVL in our builds, virtually all that you saw this morning on the mass timber construction there, all that timber came from the other side of the planet. Much faster grown and locally engineered softwoods have dramatically lost market share in recent years. But I encourage you to insist that your engineer specifies and your builder orders these by brand, these engineered products, as they're available in your state. The same applies to most of our structural panel bracing. Oriented strand board, OSB, is all from northern boreal forests. Those darker red and very thin plywood that you see bracing on walls, they're hardwood species from Southeast Asian tropical forests. You see that on the left. Please have your engineer specify local, fast-grown plantation pine plywoods for structural panel bracing, so the one you can see in the middle of that image on the left. And it wants to be branded, so you can see that it is an Australian product. Again, the same for most of our cross-laminated timber and much of our glue-laminated timber, also sourced from these cold climate forests on the other side of the planet. But we do have CLT fabricators working with local fast-grown plantation pine, so there's Xlam at Albury and Crosslam in Perth. Here on the top right of that screen is shining gum in a Tasmanian plantation. Originally it was planted on bare farmland for the fickle wood chip industry for pulp, and it's now ready for harvest after only 15 years of growth. There's a company called Cusp at Wynyard is processing it into high-value glulam beams, CLT panels, and I hope soon also window joinery timbers. So there's no natural forest carbon debt here at all. Please support Xlam and Crosslam, Cusp and other companies like that as they emerge to do that in your work. Timber engineering is an excellent space for small-scale local enterprise to thrive, making the best use of these super fast-grown but immature plantation woods that we'll need to look to until we have this climate crisis sorted. And meanwhile, we can preserve our natural forests for the many other precious ecological services that they provide. And by sourcing timbers responsibly, we're sending a clear message to forest and timber industry that we will accept nothing less for the sake of our children. So I encourage you to keep this simple guide handy and let it inform your specifications. It's a green light and a red light list of structural timbers that are available in Australia. It's regularly updated and lives on both the Mullum Creek and My Office websites. Insist on locally fast-grown plantation woods as they're listed here. There's no need whatsoever to specify imported or Australian native solid sawn forest timbers for structural applications. As many of you will know, the tropical rainforests of Southeast Asia and the Amazon are where many of our great Aussie decks come from. Certainly all those that are built in Merbau or Coomera, and increasingly also some of the other durable and stable timbers that we want for our external building applications. So Manilkara, New Guinea rosewood, those sorts of things. And gosh, even the spit roast charcoal at my local servo, it comes from really quite ecologically crucial mangrove forests of Thailand. So please avoid these tropical forest woods. If your project's in Victoria, you can support Ceres through its not-for-profit aggregator, Fairwood, which I spoke about this morning. You can check out their naturally durable farm-grown sugar gum. They're macrocarpa and blue gum, all grown in plantation on farm for external applications. Thermally modified LOSP and ACQ treated plantation pine decking is widely available also in knot-free grades if that's an aesthetic consideration. A lot of people seem to be put off by the knots in pine, but they do grow clear and select grade pines, and most of that comes actually either from Queensland and certainly a lot from New Zealand. So Obodo from New Zealand and Hine, Queensland, make a really smart decking of this kind. And most of my clients' decks, they end up weathering to a grey anyway. And then there's not much of a difference in the look of the clear grade pine and the native Australian hardwoods. They're also cheaper, the plantation wood. This Mullum Creek info sheet, it'll help you to work out what all the numbers on those little tags on the treated pine mean in terms of chemical toxicity. So copper, chrome, arsenate, or CCA is obviously the treatment you want to avoid. If your clients are comfortable with composite wood plastic decking, Modwood is manufactured in Melbourne from local plantation pine sawmill waste and recycled PVC milk bottles. It's also available in Bell 40 bushfire resistance. Other wood plastic deckings are best avoided because they're manufactured mostly in countries where OH&S around volatile plastics is poor, and they also often draw on virgin forest and petrochemical resources. And what about timber from Australia's native forests? This is where a lot of people become quite emotional around. Deforestation is still happening across Australia, but it's occurring mostly in the relatively sparsely vegetated, dry open woodlands and savanna country of southern Western Australia, inland New South Wales, Queensland and the NT's top end. It's a very different landscape to the tall, wet and dry sclerophyll forests from where we source our timber and our pulp, but the timber for construction. By comparison, these tall forests are not at all expansive, but they hold most of our country's forest biodiversity and certainly most of our forest carbon. So our tall, dry sclerophyll forests, they're particularly vulnerable to catastrophic bushfire, as we know, and the frequency and the severity of which have ramped up substantially with the hotter and the drier summers that climate change is serving us up. The tall, wet sclerophyll forests are slightly less vulnerable, at least for now, to this frequent cataclysmic wildfire. But they are by far the most broadly impacted by logging for timber and pulp. And they're the forest types we need to focus on, because that's where our wood's coming from. Tall, wet forests of Victoria's Central Highlands, just north of here, store more carbon per hectare than any other terrestrial ecosystem on the planet. They're also the forests from where most of our mountain ash and alpine ash are sourced. And they're probably the native hardwood timbers most widely used in architecture across Australia. According to the University of Melbourne's Professor Patrick Baker, even more so than wildfire, broad-scale and intensive logging practice, as you can see here, it reduces the regenerating forest to a mostly singular and immature age class that'll for the most not produce quality saw logs in its 60 to 80 year harvest cycle, certainly not the next 60 to 80. It won't accrue as much forest carbon post-harvest. It won't recover well as a biodiverse ecosystem in the aftermath of inevitably more frequent and severe bushfires that we've got ahead. And there's also little underway in forest management practice between the harvest cycles to improve the quality of the timber yield or the prognosis of this natural ecological system, which together with the world's other tall forests will be crucial to our very existence in a future stressed by greater heat and summer droughts. Now, the heart of the problem here, as I understand it, is not the practice of clear-cut logging per se, but rather the pace, the sheer scale and the intensity of it across tall forest landscapes of Australia. Without clear evidence on the ground of truly transformative change to the management of production forests and some equally clear messaging about the same, I can't see native forest logging continuing in most Australian states for much longer at all. Alone, the shifting socio-political sentiment simply won't allow it. The claim that building with wood is good because it locks up carbon sequestered in a tree, I would say that is flawed in the context of native forest logging practice in Australia and other countries, as it occurs for the most in the time frame of this climate emergency. So around 50% of the carbon or the biomass that was stored in this native forest mid-last year has now been pushed into a windrow and it's been burnt, 50%. The few retained seed trees you can see there, they will have almost certainly died as a result of the post-harvest regeneration burn, or they'll soon succumb to increased exposure that they've not grown up to face. Of the logs that are removed from the site, only around 20% are of sawlog quality. The yield from these sawlogs, first to rough sawn hardwood, then via kiln drying and machining to product that's going to be ready for the building site, that'll be in the order of 30%. If you lose another, say, 10% on the building site to construction, some offcuts, wastage, then you're left with only 3%, give or take, of the forest carbon debt incurred last year locked up in construction this year from that site. Natural forest regrowth here is going to take 90 years to repay that full carbon debt. And that assumes the forest suffers no bushfires damage between now and then, and that the heat and the drought through those 90 years won't be worse than it was in the last 90. The science tells us that's very unlikely. And this debt repayment involves a time frame way beyond what we have left for impactful global carbon drawdown. Australia and New Zealand have expansive plantations of exotic pine, and they do provide for a good part of our construction softwood needs. Again, both simply sawn and to a lesser extent, Australian-made engineered product. But here, we've been loath to expand our plantation estate in Australia, which since 2006 can only happen on historically cleared land. And we're not doing that because of the long time frames and the investment risk attached to this business at the vast scale it likes to operate at. It's much easier and safer, it seems, for the man at the timber yard to make a phone call overseas to one of the big processors of Baltic or spruce from those natural boreal forests of the Northern Hemisphere. And by way of plantation hardwood for timber production, we've had ridiculously little happening in Australia over recent decades. We desperately need a dramatic increase in new plantings across the rural landscape of both locally indigenous, native and exotic tree species on farm properties. Also in patchwork arrangements with green fire breaks to help protect against progression of megafires through the landscape. So these can be trees that are grown on farms for conservation and for profit. At Jigsaw Farms in Western Victoria, they're really going for it there. And across the agriculturally difficult, steeper slopes of South Gippsland, many small farmers are having a go. Growing some really valuable architectural wood. So timber from a web of small growers and sawmillers. So fair dinkum good wood that's then gathered and sold by the likes of Ceres Fairwood, of which there could be many of those, again, across the country, repeated. So from my perspective as an architect, I'm confident that going forward, an increasing public and private client base will be keen to invest in and even pay a premium for wood that's produced locally from much more ecologically and climate-conscious forest and timber industry. I reckon these clients will embrace that objective with all building materials in the same way that they already have with energy and water efficiency, rooftop solar, those sorts of things. The responsible timber selection guides that we applied for Mullen Creek, and I spoke about this morning, they're freely available. They're commissioned by a family of environmental philanthropists, so you can be pretty sure that these guides are not influenced by commercial interests. They include a pretty comprehensive list of readily available timber products that meet quite stringent environmental and social criteria, and ones that are suited to all applications and budgets. And that list is regularly updated. Now, from my take here on responsible timber selection, you're excused for parking me in the camp on the left side of the screen. But by pressing pause on native forest logging, as WA and the Vic governments have committed to in 2024 and in 2030 respectively, we're also pressing pause on that noisy tussle for a simple fix, which is what big forest business and environmentalists fight for to prevail. I'm hoping that it'll allow us all to lend an ear to the likes of Patrick Baker, who I mentioned. He's from the School of Ecosystem and Forest Sciences at Melbourne Uni. Michelle Freeman, the Vice President of Forestry Australia, and Rowan Reid, who's a sage for every master tree grower on farm. They're advocating for transformative change to the management of all forests in Victoria, plantations, native production forests and conservation reserves, for a suite of smart silvicultural practices that do yield wood for construction, but first and foremost make our forests more biologically diverse and abundant, as well as far more resilient to the increasing threats of climate change. On my office website, you can find a YouTube titled Local Enterprise with Trees and Timber, and it describes these experts' really balanced perspective in more detail, and I'm increasingly taken by it. And on the same web page is another YouTube that more methodically covers environmentally responsible timber choices for most structural, architectural and joinery applications. So it's a more detailed discussion on timber selection than I've got time to cover here. And finally, I want to stress the obvious, that responsibly selected materials, whatever they are, they won't make our designs and our constructions sustainable if they're not used frugally, if they're not sufficiently durable for a long service life, if they can't be easily disassembled for reuse at the end of that service life, and particularly if they produce buildings that are inflexible in their function and or beyond what we need for a modest life. Quickly to illustrate, just on designing lean with materials, for medium-rise construction, say 5 to 15 floors in height, cross-laminated timber from fast-grown plantation wood can make for carbon-friendly and material-efficient structural system. But for low and high-rise, where it also seems to now be the rage amongst architects, CLT is likely to be wasteful of precious wood resource. Here's a 2-storey home with essentially 2 homes worth of wood in it. So one house worth is in the CLT. Unfortunately, it's spruce. There's a house in Tasmania. And another is in stick framing, which also looks to be of spruce. It sits alongside the CLT to provide those cavities we need for thermal insulation and for services. If only the upper floor joists and the roof rafters were beefed up just a whisker, there'd be no structural and no thermal purpose to the CLT whatsoever. Sydney's 40-storey Atlassian headquarters, that'll be a hybrid timber tower. So it's going to have a concrete core, a steel exoskeleton, concrete 4 plates at 4-storey intervals, and with these 3 stories, so structurally you can consider them low-rise, inserts of CLT in between. In both these cases, the low and the high-rise, I can't understand why simple, conventional and material-efficient low and medium-rise timber frame construction systems can't be used. The argument that the more wood we shove into a build, the better, because it locks away atmospheric carbon, that's bolstered by a zero carbon building mantra, which, as I explained earlier, completely ignores forest carbon dynamics as their most meaningful for the few decades we have left to impactfully fix the planet. I even hear CLT promoted as high-performing for passive host projects because of this thermal mass that they have. And yes, CLT does have some heat and cool storage capacity, but with the thermal conductance of pine, and most timbers, but pine very much, being only 12% that of brick and 9% that of concrete, and with interior shrouding of CLT behind insulation and surface cavities, a common thing, this thermal mass is unable to transfer heat effectively to and from the interior air. And a topic for another day. In all its functions, high-rise can never be ecologically or socially sustainable. This morning, I will have indicated that I like it when things are kept simple and local and joined with nature. And this afternoon, that I'm keen on techie things for a sustainable future. So before we go to questions, I can't resist but to finish with these guys from Wisconsin in the USA who fuse my passions with such grace.